Alright, here I am showing off my new LED hook locator system. So right here I've got a phone, and this is all the products, basically 79 rows A through C. So that's a column number, and then row A, B, and C. So if I click it, get this page that comes up, it goes away really quick. I'll do that again. It says the assigned hook range is 78 to 84, A through I, and it's highlighting that hook now. And if we come over here, we will see just that. So down there is the power supply and the brains, and then here is the LED matrix. So right now it's offset by 78 LEDs because that's the section that this section of LEDs is assigned to, and that's it. So if we maybe find a product that is in that same section, like this one, now this is a different hook for a different store, but at the moment it would work with either. So we go ahead and click that. It's going to attempt to do the same thing, and right now it's highlighting section 79B. So how this works is we have hooks A through I. So the first hook starts above the first row of LEDs. The last hook ends at the after the last row of LEDs. So if a hook is being highlighted and it's in the A row, you'll only see that top section of LEDs lit. Let's do that one more time. Let's pick 83A. Yeah, so 83A, we'll see it's only highlighting that top row because the products are only above it. But if we were highlighting B, we would have the top row and the second row lit up to kind of surround the product to show where it is, and then the animations would automatically do their job. So this is calculating basically a custom grid of LEDs in a custom pattern. The way they work is the Raspberry Pi. Let's get a little more light here. The Raspberry Pi down there first talks to a burner LED, which is in this tube of heat shrink, and that is boosting the data signal from 3.3 volt data from the Raspberry Pi to a 5 volt signal coming out. Basically there's too much drop over the copper in this long of a strip to talk to the first LED and continue that message. So that's why we need a burner LED at as close to the Pi as possible, and this is kind of a distance, but this is enough. I think it is, I would say, probably within 6 inches to a foot, depending on the gauge of wire you've got. But basically we've got one LED that doesn't do anything. It could be still for status if we want, but we've got this huge grid of LEDs if we really want. If there's no Wi-Fi, what I'm gonna have is a big marquee that says no Wi-Fi scrolling across, and then basically it just creates an HTML5 canvas out of the grid of LEDs. So I'm working with a virtual HTML5 canvas that I can draw shapes, draw text, animate them. I can move the objects, I can move the entire canvas. So what I'm doing is kind of flipping the canvas, because the way I'm talking to it, I'm having to flip the whole image upside down because the text ends up backwards, and then actually I have to flip it horizontally and vertically to get the canvas to display correctly, and that's partially because of where I'm starting the LEDs and how I'm addressing them. and all that. But pretty cool. So one last little hook. Let's keep going. We've got 82A, and it basically automatically tries and closes that window so we can hit another domain name that is going to be on the local area network of the store. And let's see, so we've got 82I. So 82I, just as we would expect, it's going to highlight only that last row. And it does this for about 30 seconds. And it cycles through colors, animates the colors, and then animates the actual effect itself. And so all this is written with NodeJS on a Raspberry Pi over Wi-Fi. Thanks for watching. Like and subscribe for more.